Alright, so in this video we're going to be continuing on with our simplification of radical expressions where there are sums and differences involved. So in this particular example we're looking at 3 times the cube root of 7 minus 4 times the cube root of 56 plus the cube root of 7 times x to the 6th. So how do we handle this sort of thing? It's going to work exactly the same way as in previous examples. So the first thing we want to do is simplify the radicals that we have in sight here. So let me rewrite everything. Okay, all I did was rewrite everything. First thing I want to notice is that I'm looking at a third root of 7. 7 is prime, so I can't break that down any further. Moreover, this 3 just tells me I have 3 cube roots of 7. Here, I'm looking at cube root of 56. Hopefully I can break this 56 down into something that'll cancel out at least a little bit of this cube root here. So 56, doing the whole factor tree thing. What does that give me? It gives me 28 times 2. 28 breaks down into 2 and 14, and 14 breaks down into 2 and 7. So I have 3 2's, which is awesome because I have a cube root here. I have a spare 7. So this 56 is going to break down into 2 cubed times 7. Okay, so let's rewrite that for the time being. We have 3 cube root of 7. We have 4 cube roots of 2 cubed times 7. All right, now we're looking at this guy here. How do we deal with this? Let's add a plus here for the time being. So I have 7 times x to the 6th. So I want factors in groups of 3 so I can cancel out as many of this as many x's as I possibly can using the cube root. So rewriting this, I have cube root of 7 times x to the 3rd times x to the 3rd. So I had 6 x's before, I just broke it into a product. How many x's do I have in total? Well, I have 3 here, so I have 6, and it matches what I have here. I broke it down correctly. So now I'm going to use our product rule for radical expressions. As before, can't really do much with this first term. So continuing along, this gives us, we have 4 cube roots of 2 cubed times cube root of 7 plus cube root of 7 times the cube root of x cubed times the cube root of x cubed. So all I did was break this apart over the product. As mentioned before, you cannot turn this into one giant radical because that's just not how radicals work. You can't do that over sums and differences. So the best bet that we can do is break things up over the product. That's all we did. Okay? So we have 3 times cube root of 7 minus, 4 cube root of 2 cubed, that's just 2. Cube root of 7, 7 is prime, so we can't do anything more with that. Then we have cube root of 7 here, can't do anything more with that. But this x cubed, cube rooted, that's just x. Not absolute value of x because we have an odd power and an odd root, so we don't have to worry about that here. Similarly, we have an x for this guy. Simplifying, this gives me 3 times cube root of 7 minus 8 cube roots of 7 plus x squared times the cube root of 7. Okay, so now this is a little bit more complicated because I'm looking at this variable here. I'm used to seeing numbers in front of all these radicals, but the principle works exactly the same. I have 3 cube roots of 7 here, I have minus 8 cube roots of 7 here, and I have x squared cube roots of 7 here. So if you think of this as just some weird number, and that's how many cube roots of 7 I have, you're in good shape. So we want to combine like terms. Or, alternatively, you can factor out the cube root of 7. Either way, you end up getting the exact same thing. So I have cube root of 7 times the quantity 3 minus 8 plus x. So in this case, I just factored it. Okay, factored it out. So what I'm left with here is cube root of 7 okay, times the quantity. Well, 3 minus 8 is minus 5 plus x squared. Okay? So all I did before, factored out the cube root of 7, combine like terms, simplify as possible. So here we are stuck. We've factored out everything we can, we've combined like terms, and at this point we are done with this example. Yeah, so all we did, factor treed everything inside the radicals, broke it down into powers of 3 so we can cancel the cube root, simplify. That's all we did. Okay, so with that, our example is done, and if you found this video helpful, please like and subscribe. See you in the next one.